In this lesson, we shall focus on grade 10, mathematics paper 2, in discussion with provincial exam approaches, and also looking at this past exam paper. But also we will take into account that this paper was written out of 50 marks and the time allocation was 1 hour. And we proceed to solve this particular past exam questions as follows. Right, question 1 was as follows from the provincial office. Study the diagram below and answer the questions that follow without the use of a calculator. Now, determine the value of sine theta. Determine the value of sine theta. Right, we want to find the sine of theta. But now, to find the sine of theta, we need to remember SOHCAHTOA. Okay. So we have the sine of theta. Okay, the sine of theta is opposite of hypotenuse. So what we do is we construct our triangle like this. Okay. Now, if this is the case, so this becomes our y, and that becomes our x, and that becomes our radius. Okay, so that the sine itself becomes opposite of hypotenuse, and you imagine the theta as being sitting in that position there, so that you have the opposite over the hypotenuse, which is actually, now this is x and y, opposite of hypotenuse, which is y over r. At this point, we're able to see that our radius is unknown, but you can easily be able to find the radius by using Pythagoras theorem. X squared plus y squared is r squared. It's called Pythagoras. Pythagoras. What is x? Right, so this tells us x is first, is minus 4. Y is minus 3. What is x? It's a minus 4. Y is minus 3. It is r squared. Okay, if you square minus 4, you get a 16. And we have r squared. 16 plus 9 is what? Is 25 equals r squared. So you take the square root of 25, the square root of r squared. Right? The square root of 25 gives us a 5 equals r. And here we have r equals 5. What is then the sine of theta at this point? Right? The sine of theta, according to SOHCAHTOA, is opposite of hypotenuse, and therefore we're able to see that it is opposite of hypotenuse, and it is minus 3 out of 5. Any question, Paul?
Okay, so liko pampiring ne ba kana ba surely ba ka etsa sona. So ba etsa so ke like exactly the way we entseng ka teng.
Definitely. Exactly the way the entseng ka teng, because they expect you to use Pythagoras. And what is Pythagoras? Pythagoras is simply x squared plus y squared equals r squared. When do we use Pythagoras theorem? We use Pythagoras theorem when we want to find the third side of a triangle. So given two sides, like in this case, they gave us the point P, and this point P is part of this diagram. This point P has like x and y. So we need to find x, y, and r. So, okay, we got x and y, and need to find r. And to find r, we use Pythagoras theorem. Okay, and obviously we know that the sine is opposite of hypotenuse. So you deal with the sine theta, you have opposite of hypotenuse, which is minus 3 out of 5. And that is the answer. It lies as so, always. But remember, this paper is a provincial office. It's not that I'm just doing these questions. It's from the examiners provincial office. It's a Gauteng, where these big guys are. So the guys who come up with the curriculum, the guys who talk to the schools about what must be taught. So it's a very, very good paper that we're discussing right now. And the paper tomorrow is going to be like this. Not exactly the numbers, but yeah, the structure is going to be the same. Okay. Let's move on, Paul, to the next question. Right, the next question is 1.2, and in 1.2 they gave 5 cosine. Okay, it's this one, which is 5 cosine 90 degrees minus theta plus 3 the cotangent of theta. Okay, what is the cosine of 90 degrees minus theta? The cosine of 90 degrees minus theta. So you think about this one and think about what this is supposed to mean. So if you have 90 degrees minus theta, what does it become? Yes, what does it become? What do you think, Paul? Okay, it's tricky, but you need to reason. Okay, because if this is the case, then what is exactly 90 degrees minus theta? So where does that angle sit? Okay, where does that angle sit? As a matter of fact, so there are a couple of things that you need to take into account here. And you need to take into account the fact that at this point, what then you have is at the sides. Okay, so this is like X and Y. Always do this. Always do this. Put the X and Y there. And then your X is minus 4. Your Y is minus 3. Your R is 5. Okay, so we got the 5 using Pythagoras theorem. And then now, when you get to this point, we are in a position to get the result that is wanted. So you look at these and you think, but you think very, very carefully. And then say, there is 90 degrees minus theta here. Where is 90 degrees minus theta? You need to think big. You need to think big. So this one is 90 degrees minus theta, is theta. Okay, so now the fact that the theta is measured like this, it is actually telling you that the angle theta sits here in the triangle. Now, to find the third triangle, you have 90 degrees minus theta. So this one becomes 90 degrees minus theta, this one here. So that when you add theta minus theta, you add everything. Theta minus theta is 0. 90 plus 90 is 180. The angles in the triangle add up to 180 degrees. Take note of this, okay? So if you then need to find this one, you come here to the diagram and say, if you look for the angle 90 degrees minus theta, it is this one here. It is this one here. Then you come and then say, SOHCAHTOA. You come and say SOHCAHTOA. So this SOHCAHTOA becomes exactly what? So the SOHCAHTOA becomes adjacent of hypotenuse, which is minus 3 over 5. And what is the cot? Cot. So cot switches the order of division here. Sec starts with H, ends with A. Cosecant, cosec, starts with H, ends with O. So this one is cosec, or what you call the cosecant. S stands for the secant. The C stands for the cotangent. Cotangent. So obviously the T stands for the tangent. Okay, this is recorded, so I'm going to make this video available for to you so that you can have access to it, and then you can watch it during your leisure. But now here, if you are dealing with a cot, you come here. So you write SOHCAHTOA, and then below the TOA you write C for cotangent. Then you switch. You put A here, which is what you call the Choshakau. The Choshakau. So when you're dealing with a cotangent, the cotangent sits here and it is adjacent over opposite. You come here and you're dealing with theta. Adjacent theta is actually this one here because this one is the opposite theta. So adjacent theta is a minus 4 over so you're dealing with the adjacent over the opposite. So this is the adjacent over the opposite. The opposite is -3, like so. Okay, now pay attention because we are dealing with very, very important things here and what this means. So we come here and take the green color. 5 cancels, 3 cancels, and this gives us -3. Negative divides negative, giving us a +4. What is -3 plus 4? -3 plus 4, it's a 1. And this one, it's a 1. So we're done with this one. Feditega ena, and answer key 1. But there are other ways to do this question because we don't want to think like, in one direction. We want to show that we are smart. And so here, for example, 90 degrees minus theta, in which quadrant is that one? So we use 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay, 90 degrees minus theta, 90 degrees plus theta, 180 degrees plus theta, 180 degrees minus theta, 270 degrees plus theta, 270 degrees minus theta, 360 degrees minus theta, 360 degrees plus theta. So if you have this, 90 degrees minus theta is in the cast. Okay, you remember the cast diagram. So this is cosine theta, all positive, sine theta, tan theta. So if you're dealing with this, in which quadrant is 90 degrees minus theta? 90 degrees minus theta is in the first quadrant where all the trig functions are positive, but at 90 degrees, there are things we call the co-function changes, and therefore we use what we call the Coco rule. Right, we use the Coco rule. Now, I want to mention the Coco rule and its significance. Right, Coco rule, what's the meaning of Coco rule? Coco rule tells us that if there's no co, put on a co. If there's a co, you remove the co. So this one is written as cos, but in mathematics, we know that it is cosine. It is cosine of 90 degrees minus theta. So if they write like this in full, it was supposed to be cosine of 90 degrees minus theta, but we write in short because the mathematicians decided that these things must be done in short. Coco rule says now there is a co in the word cosine. There is a co, and you remove the co. If you remove the co according to the Coco rule, you remove the co at 90 degrees, and you're left with sine. So this is 5 sine theta. And then we have 3 cotangent of theta. Okay, and we have this. And then you can come here. Come to this diagram and say, what is this? What is, if this is the angle theta, so katoa, so we have sine is opposite of hypotenuse. Right, so you have opposite of hypotenuse, and therefore opposite is actually what? Opposite theta is -3. The hypotenuse, it's the side opposite the 90-degree angle, ilikana 5. That is the hypotenuse. Then you have 3. What is the cotangent? Cotangent is adjacent over opposite. The cotangent is part of the Chaucer curl that sits below the tangent function. So the cotangent, right? So cotangent is what? Right, to take note of the fact that the cotangent is as follows. Right, so the cotangent is what sits here, and the cotangent is adjacent of the opposite. So if this is theta, adjacent theta is actually, there it is a -4, -4 over the opposite theta is a -3. This is exactly the same as this. This is exactly the same as 5, open bracket, -3 out of 5, plus 3, open bracket, -4 over -3. And the answer is 1. And we're done. And so we did this one here using a variety of the methods. Okay, the aim is to build your understanding, is not to confuse you. So yeah, just pay attention to the way we've done this, and we move on right now to the next question. Okay. Right. So in question 2, we need to determine, these are the things you'll meet in the exam. Okay. In the junior exam, determine the acute angle beta to 2 decimals. There's an angle that's referred to as acute. So determine the acute angle beta to 2 decimals. Okay. To 2 decimals, not more, not less. So let's find the angle beta. Now, let us, okay, so you must learn how to use your calculator, and we're going to deal with the calculators just now over here. Okay, now, let us do this here. Okay, in 2.1, that is what we're doing. So if the examiner gives you the sign of the angle beta, okay, this is the Greek symbol beta. Right, so beta minus 17.8 degrees equals 0.215. Okay, we need to solve this one. We need to determine the acute angle beta. What do we do? What do we do? So we use a calculator, but first things first, we need to find what we call a reference angle. And the reference angle is obtained when the sign is moved to the other side and you have what we call the arc sine of 0.215, like that. Okay, so this gives us the reference angle. What is the arc sine of that? So yeah, we're going to show that one. So there's a calculator that we're going to use. Here's our calculator. And with this calculator, we're going to say, if we have, for example, the shift sign.
Yeah.
Yes.
12.41. I get it to 2 decimal places.
Yes. What did you get in Po again?
12.41.
Good. It's 12.41. Can you round it off anyway, in any way or shape or form? Yes, it's 12.41. Yeah, we can write off to 12.42, for example. I mean, it's possible to do that because the decimal digit after 1 is a 5. So we can write it is 12.42. We can write it like that. 12.42 degrees. Okay, but this one is a reference angle, and therefore, how many answers are we able to get from there? How many answers are we able to get from there? Okay. So, okay, yeah. Now, we use casts. Okay, now we have that the sign is, this number is positive, this ratio is positive. So it means that we expect an angle in the first quadrant where all are positive, another one is in the second quadrant there. Right, which means therefore we shall write the sine of beta minus 17.8 degrees, which equals 0.215. Okay, and then when you get to this point, we write beta minus 17.8 degrees equals, so this one you would get the arc, which is 12.42 degrees, okay, which is an angle in the first quadrant, because 0 degrees here, 90 degrees there, 180 degrees here, 270 degrees there, and 360 degrees. Okay, there's certain things that are important here. Now, the 12.42 degrees, which is our reference angle, is an angle between 0 degrees and 90 degrees. It is an angle, therefore, in the first quadrant. So if it's not only the first quadrant we're going to be dealing with, so also going to be dealing with the next quadrant. So we could also have beta minus 17.8 degrees equals, so an angle in the second quadrant, which is 180 degrees minus 12.42 degrees. Beta equals 12.42 degrees plus 17.8 degrees. Beta equals, so what answer do we get? Okay, we're gonna get the answer. So beta equals this one here, which is actually exactly, so we bring the 17 to the other side, so it becomes 17.8 degrees plus 180 degrees, minus 12,42 degrees, and beta equals this, and beta equals that. Yeah. So what do you think we're getting here, Paul, is the answers?
30,22.
Okay, good. We're just checking that one. I'm gonna press on. I need to check as well and be sure that Paul is giving me the correct answers that are needed here. So we have 12,42, and then we add 17.8. Right, and then we press the SD button. Well done. 30,22. Right, so here we have actually 30,22 degrees. What about this side? Because here we have 17,8 plus 180 minus 12,42 degrees. And we need to get the answer to this one as well. Let me just actually use a calculator as Paul is getting that. You got your answer already, Paul, to this part. 17.8.
185,38.
Okay. Thanks so much. Thanks so much, Paul, for the answer. I'm just trying to verify that we are actually getting the same answer. So it's 12.42. Yeah, which is exactly this one. It's 185. What did you get again? This again?
Yeah, ke yona eo.
Okay, ke yona ene. 185, 185,38. 185,38. So yeah, you're getting 185,38 degrees. So these are the okay, but remember that the examiner said determine the acute angle beta. So we can see that this angle is not applicable. Why is it not applicable? Because it is not acute. What is an acute angle? An acute angle is a small angle. So it is an angle that sits between 0 degrees and 90 degrees. So this is the only answer, and this one is not applicable because the examiner said they want an acute angle. So they want an angle that is smaller than 90. So this 185 is way too big, way bigger than 90 degrees. Next question, Paul. Right, in 2.2 now, we need to determine the acute angle beta correct to 2 decimals. This one, tangent of 3 beta equals that one. So if you have the tangent, right, let's just do that one. We're doing 2.2 right now. If you have the tangent of 3 beta equals the square root of 3, equals the square root of 3. And then now we get our reference angle still. And the reference angle is arctangent of the square root of 3, which means we have the reference angle of arctangent of the square root of 3, and we get the answer. And so this is going to be, for example, it's going to be shift tan of the square root of 3. You close. Okay. That's interesting. So what did you get, Zempo?
60 degrees.
60 degrees. Yes. It's exactly 60 degrees. Well done. Very smart. Thanks so much for realizing that one, Paul. It's actually 60 degrees. That's beautiful. 60 degrees. Okay, we found our reference angle, and our reference angle is actually 60 degrees there. And obviously, because the 60 degrees is acute, smaller than 90 degrees, so we're good. And then now it means, therefore, we can come here and say 3 beta is 60 degrees, and then is 3 beta. We are interested in the beta, so we divide the left by 3, but also we divide the right by 3, and therefore this is 20 degrees. It's 20 degrees. Yeah. So yeah, that's the answer. So this one here, we got that beta is 20 degrees, and we are gonna move on. Any question here, Paul?
I can understand.
Yeah, I understand. Okay, good. Thank you so much, Paul. Next question. Right, in 2.3 now, we want to do this one. And 2.3 is a very interesting one. So if you have 3 the sine of beta out of 2 equals 2,012. We want to find the value of beta, and to find the value of beta here, we do the following. Right, first things first, because of the 3 in front here, we must divide by 3, and whatever we do on the left must be done on the right side of the equation. We divide by 3 both sides, 3 cancels, and we have the sine of beta out of 2, and this equals whatever we get when we divide the right-hand side by that. So let us perform division. So we're going to divide, for example, 2.012 divided by 3. What is the answer? Okay, so the answer is actually 0,6706 recurring. Right, so it is 0,67. 0,6706 recurring. Right, so we first get our reference angle all the time in trigonometry. This is the arc sine of 0,6706 recurring. Right, so which means therefore our reference angle equals what? Let's just get that one. Okay, shift sine, which is 0.67. Can write like that. And it's about 42,067. Right, so getting the reference angle to be exactly that one. Right, which is 42, that. Right, 42,0. Check it again. Bring the calculator again. So it's 42,07. 42,07. So that in the end, we need to find the beta. So which means that we have beta over 2, which is what the angle, that's the angle we have here. It is actually 42,07 degrees. And therefore beta, you cross multiply this, it becomes 2 times 42,07 degrees. And this equals 2 times that. 2 times that. Okay, so if you have this answer here, and you take this answer and you multiply by 2, and you say times 2. It is 84. Yes?
80, nna yaka itse ke 84,14.
Well done, 84,14. Well done, Paul. That's okay. 84,14. Right, 84,14 degrees. That's okay. Right, so very, very interesting question here that we are doing. And this can be done using the calculator here, and the calculator can be used with much ease and great simplicity as we are able to calculate these things here. Okay, right, so just putting the calculator on the side, and right, so if you have, we saw again that it was 2,012. So if you do 2,012, right, 2,012, and you divide by 3, which is 0,6706. That is what we got, 0,6706 recurring. And then at this point, went on to then say shift sign of the answer, and we got exactly 42,07, 42,11. Okay, it's an approximate result. So This is okay, but this is more accurate because I did not round off anything. And then when you get to this pointer, you've got the 42,11. And then now you then take the 42, you multiply it by 2. Right, which is 84,23. So all these are actually approximate answers, but this is more accurate. So which is 84,23. You can write it as 84,24 degrees. A very, very accurate answer. So another student can write 84,24 degrees. 84,24. 84,24 degrees is a more accurate answer. But because I did not round off anything, I just calculated from the beginning to the end, saving every digit on the calculator screen. Okay, yeah, that's fine. Let's move to the next question. Right, as part of what we need to learn. Okay, now I want to make mention of, okay, the examiner here said we need to deal with determine an acute angle beta. The examiner would have said an obtuse angle. So what is an obtuse angle and what is the difference between acute and obtuse? Has the teacher taught you reflex angle? Have they taught you obtuse angles? I mean, what kind of an angle is obtuse? What do you think, Paul?
I can't say me.
All right, that's fine. Okay, yeah, I'm just teasing you, teaser. I just want to, but I want to maybe obviously, but yeah, obtuse means that it's an angle that is bigger than 90 but less than 180. But now these acute angles are smaller angles, 0 degrees, and if there's 90 degrees, they're just between 0 and 90. They're called acute, but obtuse means that it's an angle that is more than 90 but less than 180. So 0 degrees, 90 degrees, 180 degrees. So yeah, we have an angle that is more than 90 but less than 180. That kind of an angle is called an obtuse angle. Okay, but yeah, these were just acute. So yeah, be good. Okay, let's move on to the next question and solve as many questions as possible. Right, let's look at question 3. Determine the value of theta if theta is an element of the interval from 0 degrees to 90 degrees without the use of a calculator. Let's look at this one. Determine the value of theta if theta is an element of 0 degrees to 90 degrees without the use of a calculator. Okay. Yeah. Okay. Anyhow, we have this one here. And this, to do this one, we remember our special triangles. 60 degrees 30, 2 square root of 3, 1, 90 degrees. This one here, square root of 2, 1, 1, 45 degrees, 45 degrees. 30 degrees, soccer tower. Right, so the tangent of 30 degrees. Okay, this here is 30 degrees, and we're dealing with the tangent. The tangent is opposite of adjacent 30. So what do you think 30 is here, Thor?
1 over square root of 3.
Well done. 1 over square root of 3 because it is opposite of adjacent, right? Okay, this one is tricky. What about cosecant 45? Yeah, this one is
Cosky opposite over adjacent.
Yes.
And then it over
So now we need to realize that cosecant is this one. Cosecant theta. So it's the opposite of like sine. Okay, and then this one is the cot, but cot is the opposite of the tangent. This one is the secant, which is the opposite of the just the reciprocal of the of cos. This is cos, and then this one is sec. And this one is tan, and this one is cot. Okay. Okay, well, let's deal with cosec. So cosec, it's like sine is opposite of hypotenuse, so cosec is hypotenuse of opposite. Hypotenuse of opposite. So sec, cos is adjacent of hypotenuse, but sec is, you start here from the end, it's hypotenuse over adjacent. Cot, tan is opposite of adjacent, but cot is opposite of adjacent. Okay, let's deal with cosec 60. Okay, cosec 60. What do you think?
2 over square root of 3.
Okay, good. Yeah. So cosec 60, you're gonna come here and then say cosec is hypotenuse over opposite. Is the reciprocal of the sine, hypotenuse over opposite. So you come here and you look at 60, and you then say hypotenuse over opposite, which is actually 2 over the square root of 3. Well done. 2 over the square root of 3. 2 over the square root of 3. So it is 2 over the square root of 3. Okay, well, let's deal with cosine 45. Okay, what do you think cosine 45 is? Cosine is adjacent of hypotenuse. So
1 over square root of 2.
1 over square root of 2. Well done. Okay, just teasing you. I want to see what Mpo can do. Okay, well done there. That is the correct answer. That is the correct answer. Okay, next. 45. Sine is opposite of hypotenuse, right? So 45.
1 over square root of 2.
1 over square root of 2. Well done. Thanks, Mpo. Right, so now dealing with the top parts. Dealing with the top parts. 1 times 2 is 2 over square root of 3 by square root of 3 is a 3. Divided by 1 by 1, it's a 1. Square root of 2 by square root of 2, it's 2. So this is 2 over 3. You divide by 1 over 2. 2 over 3, you multiply by 2 over 1. And the answer is what? Is 4 out of 3. Actually, 4 out of 3. Okay. Any question there? Any question there? Yeah.
Ba ka e hlahisa e le so.
Hey, ba tla hlahisa e le so.
Hore re hopotse, ne?
Hey, ba tla hlahisa e le so. The triangles tsena.
Oh, ne ke batla ho botsa hore di draw na.
Yes, the triangles tsena di draw, but I mean they are not worth marks. Abantu fit maraka ka di triangles say. And ba batla di answers go di 1030 ilikana li in, you know? Like 1030 here, it's 1 over square root of 3. But also cosecant 60 is 2 over square root of 3. But just that these triangles, the examiners can always give you marks because the most important thing is writing much. The best is write your triangles on the side so that you can get the answer. Because they're saying without the use of a calculator. But you can cheat this question. If your calculator can give you the answers, like my calculator, let me try this calculator here. So you can cheat. Yes.
O sebedisa calculator, a o ngole ka di comma, o ngola
Hey,
ka
if you somebody's a calculator, I want to comma, right? Okay, like I want to try this calculator and see what it's gonna give. If I say like 1030, about the comma, you see with the calculator, it's gonna give the square root of 3 out of 3. Okay, but the answer is 1 over square root of 3 for us. But the square root of 3 over square root of 3 has been The calculator has rationalized the denominator. Okay. And then we can come to the calculator and do like cosine 45 degrees. You can do cosine 45 on the calculator. And it's going to be cosine 45. We wrote 1 over the square root of 2, but the same as the square root of 2 over 2. Okay, because the calculator rationalized the denominator. We move to the next question. Next question. Okay. Okay, next we must deal with the graphs. And let us analyze the graphs. Now, here's a graph. Here are graphs in particular. So they are like 1, 2 graphs. There's graph F and G. The diagram below represents the graphs of f of x equals a sine x and g of x equals b cosine x for x between 0 degrees and 360 degrees. Okay. Write down the values of a and b. Okay, we need the values of a and b. What do you call a and b? A and b, they're called the amplitude. Right, so what is the amplitude of now f? It's this one. What is the amplitude of this graph? The amplitude is how high the graph is going to go. It's the vertical distance from the equilibrium position to the highest crest or the lowest trough. So, which means a is what? A is 2. And then now we have b. So b is also, what would b be, for instance, for this particular graph here?
1 or
negative. Okay. But now note that,
yeah.
yes, note that at 90 degrees, the sine of 90 is 1. But now it has become negative here. And at 90, the function is negative. It means that a must be negative 2. A must be negative 2. Okay, but now you see, you can use a trick here and take a point just to make sure you get the correct answers here. Okay, you take x is 90 degrees. Take x to be 90 degrees, and then y is minus 2. Okay, take f, this function, write a sine x. This is x and y. Okay, y is minus 2. The sine of 90 degrees. What is sine 90? It's a 1. And therefore, what we're able to see here is that minus 2 equals a. Right, so if they say write down the values, so we can see that a is minus 2. But also the knowledge of the fact that the sine of 90 is 1. The graph was supposed to be like here. But now it's on the other side, meaning it was multiplied by negative, meaning a is minus 2. What is b? Okay, so b now, like, what graph is this? So we're dealing with the graph G. Like here at 0, this function is 1. At x equals 0, the function is 1. So what is x? What is b rather?
Negative, positive 1.
Positive 1, well done. Positive 1. Positive 1, because you can see that it is 1 there at 0. You get the point. And also, yeah, if you're not sure whether it's negative or positive, take a point. Like this point. X is 0 degrees and y is 1. Take 1 point and then substitute. It can be any other point in the middle. You have g of x. G of x is b cosine x. Okay, this is x and y. Y is 1, 0. Cosine 0 is 1. So you can see that B equals 1 either way. You can take 0, 1, or any other point in the middle on the graph of G. You can take even this point there, this point there. At 180 degrees, it is -1. You can take all those points, they'll give the same value, B equals 1. Next question. Okay. Right, so in the next question, now we're going to deal with 4.2. In 4.2, we want to, for which values of X will G be a decreasing function? G a decreasing function? Okay.
-1.
Okay. Thank you. So G is decreasing here when it's going down, but here it's going up. So it's increasing here. We put plus signs like this. So for which values of X will G be decreasing? So you can see that G is decreasing when it's going down slope. When X increases, the function is going down. And it is going down between 0 degrees and 180 degrees. Zero degrees or 80 degrees. Right. What is the amplitude of F? What is the amplitude of F? Now, F is this one. What is the amplitude? It's a vertical distance. Now, the amplitude is always positive, so the amplitude is 2. The amplitude is 2. So you write here amplitude equals 2. The amplitude of F equals 2. You can even write here and say amplitude of F equals 2. Next question. Right, what is the range of G? G is this one. What is the range of G? What is the range of G? Okay, range is to do with set of Y values. Set of Y values. So you can see that you start from the smallest one. It starts from here to there. So what is this? So the set of Y values is from -1 to 1. -1, you're starting from -1 to 1. So this is the range, set of the Y values, and therefore it's from -1 to 1. Set of Y values for which this function is defined, and it is from -1 to 1. Next question. For which value of values of X is the difference f of X minus g of X equals 2? Okay. Where is this the case? That when you subtract these two functions, you get 2. You get 2. So you can do it maybe like here. You can see that this function here at 270 degrees, this function is 2, but the other one is 0. Okay, so at x equal 270 degrees, you can see that the f 270 minus g of 270. Okay, so f of 270 is 2 minus the g 0. And this is exactly a 1. Okay, so you have that. So because when you have to check here, what about here? You are finding the difference between the two functions. Okay, so if you come here at 90 degrees, for example, you're investigating, what is f? F is this one. So at 90 degrees, because you must do f of x minus g of x at 90 degrees. Okay, at 90 degrees, f is what? F is -2. G at 90 degrees, it's 0. And the answer is -2. The examiner wanted it to be 2, so we can only get 2. I wrote 1 here. Okay, so we can only get 2 at 270 degrees. So yeah, it is 2 minus 0, and the result is 2. Just note that. Okay, 2 minus 0, and the result is 2. I mean, that happens when x equals 270 degrees. So any question there? No question there. Okay, so next question. Next question. Okay, here you can write the range of G. G is the red one here, so it's from -1 to 1. If you don't write like this, you can write it as an interval notation. So you can write from -1 to 1. You can write from -1 to 1. -1 to 1. You can write like this, or you can write like -1 to 1 with square brackets, square parentheses. Okay, then we move to the next question. Okay. Okay, use the list of quadrilaterals given below to answer questions that follow. The first one is parallelogram, rectangle, rhombus, square, kite, trapezium. Write down the name of the quadrilaterals that have the following properties. Diagonals bisect the interior angles. Diagonals bisect the interior angles. Yeah.
I think it's rhombus.
Rhombus. Well done. So it's a rhombus. Well done. So the diagonals bisect interior angles, rhombus, and also square. And also square, because a square has all sides equal. So a square has all sides equal. It's a special type of rhombus where, because rhombus generally has all sides equal, but it's like a parallelogram like this. But yeah, the diagonals themselves bisect the interior angles, but the rhombus and square, you know, the diagonals bisect the interior angles in each case. The diagonals have the same length. Which one?
Parallelogram.
Okay, let's look at that one. Parallelogram. Okay, that's fine. Let's look at this one. Here's a parallelogram. Parallelogram has to do with opposite sides parallel. Okay.
Parallelogram a lekana.
Lekana, yes, the opposite sides lekana, right? I agree. Okay, let me see now. We can have these. Whatever the case. Okay, now we're saying the diagonals have the same length. You see, this parallelogram, you can like push this side here. If you push this side here and make it like flat, you know, you can push this top corner and make it flat. If you can imagine this is made of wires or something, and you push this corner and it makes flat. So that now this diagonal here and the diagonal, are the diagonals equal here? So even here you can push it down. If you push it down, you flatten it, this diagonal is going to be longer. So it is a parallelogram, I agree. But the diagonals are not the same length here. But now we're looking for one that is diagonals of the same length. So which one? Which one?
Rectangle or trapezium.
Rectangle. Well done. Just teasing you there. So we have a rectangle. Right. So obviously, I mean, dealing with the rectangle, able to see that rectangle and square. In a rectangle, because it's organized like this, all the angles are, and therefore the diagonals are same length, but even square as well. Okay. Diagonals bisect the area of the quadrilateral. Which one? You must choose. If the diagonals bisect the area of the quadrilateral,
Trapezium.
Right. Okay. The diagonal. Let's look at the trapezium.
Or
Okay.
parallelogram.
Parallelogram. Well done. So I agree with you there. So you can have a parallelogram. Parallelogram. Okay. Square. Rectangle. Rhombus. Rhombus. Yeah, rhombus. So these are pretty much the ones: parallelogram, square, rectangle, rhombus. These kinds of quadrilaterals that have the following properties: that the diagonals bisect the area of the quad. Next question. Okay, let's get the next one. Okay, PQRS is a parallelogram. PQRS is a parallelogram with M on PS. Here is M is on PS, such that PM is equal to PQ, and SM is equal to SR. QMR is 90 degrees. QMR is 90 degrees. Here is 90 degrees. And angle Q2 is X. Q2 is X. Here it is. Determine with reasons two other angles which are equal to X. We must determine with the reasons two other angles which are equal to X. Right? Anything you think here. Which other angles are equal to X?
M1.
The angle M1. Why would you think that is the case? I agree with you. The angle M1 is X. Well done.
As in,
The angle M1 equals X, right? And it is because of this here. Because this one is already X, and these are going to be X. Because of the alternate angles. All right, because of the alternate angles. Right, alternate angles, PS parallel to QR. Alternate angles, PS parallel to QR. Next, so M1 is X. What other angle is equal to X? There's another one because the examiner says they need two. Right, so we can see also angle Q1 is X. Okay, because of the, yes, because if you have a triangle like this, on this side is equal to this, and this is X, it means that this angle is also X, and also X because of the isosceles triangle, so which we say angles opposite equal sides. Angles opposite equal sides. Angles opposite equal sides. So if you this, because this side is equal to this, it means the angles also that are opposite this angle is opposite this side, this angle is opposite this side. So we have that angles opposite equal sides are equal to each other. Okay. Then we continue to check the next thing. We continue to check the next thing. So, yeah. Determine the size of M3 in terms of X in 6.2. Determine the size of M3 in terms of X. What is M3? This one. Yeah.
90 degrees.
It has to do with 90 degrees. I agree with you. It has to do with 90 degrees there. It has to do with 90 degrees. Mm-hmm. Yeah. But there's more that is needed at this point. Right. There's more that is needed at this point. All right. There's more that's needed at this point. So we want the size of the angle M3. Right. We want the size of the angle M3. So yeah. Any take? Right. Any take that you can give there? Right. So obviously, I mean, the couple of things that you can do here to be in a position to, because you already know that SM is equal to SR according to the way they've given it here. And also QMR is 90 degrees. So if you have SM equals SR, it means SM is equal to SR. These are equal to each other there. And therefore, you can be able to use that particular result here as a matter of fact. Right, so that in the end, then, you can be able to get the result that is wanted. Can be able to get the result that is wanted. Right, so for example, I'm able to see that the angle S, because now the opposite angles of a parallelogram, if PQRS is a parallelogram, so the opposite angles of parallelogram are equal to each other. So if this one you already know is 2x, and also this one is also 2x, because the opposite angles of a parallelogram are equal to each other. Now, if this is true, what then do we have more? So we have therefore that this is 2x and that is 2x, because the opposite angles of parallelogram are equal to each other. So if you're able to get that, then the question then becomes, if this SM equals SR, it means these two angles are also equal to each other. And therefore, what then do we have there? Okay, there are many things you can do. But you can start by saying, okay, angle M1 plus angle M2 plus angle M3 is 180 degrees. These are adjacent angles on straight line. So what is angle M1? It is X. Angle M2 is 90 degrees. Plus angle M3 equals 180 degrees. Which means therefore that angle M3, okay, this one is 180 degrees. Just write that. Okay, because this is a straight line, this. Because this PQRS is a what? It's a parallelogram. Okay, right. So, I mean, there are many ways to do this question. So, yeah, you add everything. These are straight lines. You can add this plus this plus this is 180 degrees. So, which means that angle M3 is the same as, yeah, is the same as what? Right, so M3 is 180 degrees. You collect like terms, move everything across the equal sign. 180 minus 90 minus x. 180 minus 90 is 90. Okay, so M3 is 90 degrees minus x. M3 is 90 degrees minus x. Okay. 90 degrees minus x. Next question. Okay. Yeah. Because you can add this and this, and this is already 90. You know, that is already equal to 90. Okay, let's look at 6.3. Calculate the numerical value of x. Calculate the numerical value of x. This one. What is this x? Calculate the numerical value of x. Okay.
I see 90 degrees.
Okay, let's just check. This one is already 90. All right. Right, so you have exactly that, but also you have that this one is x. Okay. And you have PM equals that, so right. If this is the case. This is 2x, but also this one is 2x. Because SM is equal to SR, that is also 90 degrees minus x. Like that. Okay, so what else do we have? Because, I mean, this PQRS is a parallelogram, so this angle here. So this is also 90 degrees minus x. So this is this plus this plus this is 180 degrees minus 2x. Right, so, I mean, the opposite angles of parallelogram are equal, so this is also 180 degrees minus 2x. Now, so in this triangle, if you add everything, you get 180 degrees. And if you add everything here, this is x minus x, which is 180 degrees as well. Right. And so also the opposite angles here are equal to each other. Okay. Right, so if you add, so this angle here is 180 degrees minus x. It's 90 plus 90 minus x, which is equal to this plus that, which is 180 degrees minus x. Okay, so now you need to calculate the numerical value of x here. You need to calculate the numerical value of x at this point if this is the case. Okay, so if you consider this plus that is actually 90 and x, which is 90 degrees plus x. And if you add this and that is going to be exactly 90 degrees plus x. Right, you see, sometimes these guys make terrible mistakes in the exam. And surely this is one special case of a mistake in this exam. Because if you check very carefully, there's basically no way, because this is x, and this, if you add all of them, you get 180 degrees here. And obviously, I mean, if you add everything here, you get 360 degrees, all these. Because if you add, this is 4x, and that will be 4x, and that is going to give you 360 degrees for a total, for the sum of all the interior angles of this shape. Right, so as a matter of fact, it's just one of those questions where, okay, if you add, this is 90 plus 90, this is 90 plus 90, which is 180, minus x plus x. Right, so this question here, you really can see that x can take on any value. So x can take on any value, because if you look at any of the triangles, let's deal with in triangle PMQ. Right, then you add all of these. You have 180 degrees minus 2x plus x plus x. You add everything here, you must get 180 degrees. And this is the sum of interior angles of triangle, which is 2x minus x. This is 180 degrees for any angle. So in other words, x is an element of R. X is an element of R. So it can take in any, so x is any real number. Is any real number. Right, so x is any real number. It really can be anything. It's not, you're not restricted to a specific value of x. A very tricky question, but something to think about. Next question. Right, so ABCD is a parallelogram with AD parallel to BC. And now let's do that. AD parallel to BC and, okay, and BA parallel to CD. BA parallel to CD. Using the diagram above, prove the theorem that states that the opposite sides of a parallelogram are equal. Let us look at that part there. Right, let us look at that part there. So to deal with that part, you have to look at the fact that BD is equal to BD. So you can say in triangle ABC and triangle CBD, BD equals BD. Okay, so if you look at the triangle AB, okay, want to prove that the opposite sides of parallelogram are equal. So you can take ABD, and now you can prove that, you can establish that D1 equals B2. Yeah, let's just say here, triangle ABD can take ABD and then take CBD and then realize that BD equals BD because it's common. Okay, next. Okay, you might not label, can use some dots. Okay, BD equals BD because it's common. D1 equals B2. D1 equals B2, which are alternate angles. AD is parallel to BC. Let's see. Okay, if we say D1 equals B2, these are alternate angles because AD is parallel to BC, yeah? Next, we have that angle B1, this one, is equal to angle D2 because this forms Z. Like so, angle B1 equals the angle D2. Alternate angles because AB is parallel to CD. Okay, now at this point, therefore, triangle ABC, ABD is congruent, or it's congruent to triangle CBD. Okay, let's just check this one. And we have angle side. Angle side. So we've proven that the triangle ABD is actually congruent to triangle CBD. And because of these congruence, we're able to see that therefore AD is equal to BC. AD is equal to BC. Yeah, because then we've been able to show that we have been able to prove the theorem which says that the opposite sides of a parallelogram are equal, so that AD is parallel to BC. And AB is equal to DC. Okay. And yeah, this. All right. Just take note of that. That AD is equal to BC and AB is equal to DC. Because these two triangles, ABD and triangle CBD, are congruent triangles, meaning that even the corresponding angles and the corresponding sides are equal to each other, because the two triangles here, the top one and the bottom one, are congruent triangles. Let's look at the next question. Right, in the next question, we have question 8, ABCD. ABCD is a parallelogram, and BC and AC. BC and AC intersected O. AF is OD. AF is OD. AF is OD. Here's AF equals OD. Right, and CO is Facebook. It's FB. Right, let's check CO, which is FB. CO is equal to FB. Right, DA and BF produced meted E. There is BF, but there's also DA produced the meted E. Here's the point E there. Okay, let us answer the rest of the questions. So prove that BOAF is a parallelogram. Prove that BOAF is a parallelogram. Let's prove this one quickly. Obviously, to prove this one here, we take note of the fact that in 8.1, AO is OC. AO is OC. Right, if you say AO is OC, and this means that diagonals of parallelogram bisect. Right, diagonals of parallelogram bisect. DO is OB. Right, also we're able to see that DO is OB. Diagonals of parallelogram bisect. Okay, because we know that ABCD is a parallelogram, so AO is OC, diagonals bisect. DO is OB, diagonals of parallelogram bisect. Therefore, BOAF is a parallelogram. Is a parallelogram. Parallelogram. Why is this? The opposite sides equal? Opposite sides equal? Opposite sides of a quad. Opposite sides of a quad equal. Opposite sides of a quad equal. Next, we need to prove that So this one's a parallelogram because the opposite sides of a quad equal. Next. 8.2, want to prove that AD equals EA. To prove that AD equals EA, we can start by saying EA is parallel to BC. EA is parallel to BC. Why is EA parallel to BC? Because it is given. It is given by dint of the parallelogram. So this is parallel to this because you have that A, B, C, D is a parallelogram. So these are extensions, and therefore this is an extension of the side AD, so it's parallel to this. BF. BF is parallel to AC. BF is parallel to AC. It's proven. EB. EBCA. Okay, if you look at EBCA, it's a parallelogram. Two pairs of opposite sides parallel. Two pairs of opposite sides parallel. Okay. EA is equal to BC. EA is equal to BC. EA is equal to BC. And then we're noting that, okay, if EA is equal to BC, we're able to know that EA is equal to AD. Is equal to AD because this is a parallelogram and the sides are equal to each other. So we've been able to show that EA is equal to AD for 4 marks. Okay, very tricky questions a little bit. You need to think, you need to reason, but yeah, we got to the answers. Yeah, I must thank you for joining us. It was awesome having this discussion right now, and we shall continue again next time. I'm going to send you the video when I'm done with the grade 11 class because I'm having grade 11 class now. All right, so thanks a lot for joining us. Until next time, have a good evening and goodbye, Paul. Goodbye.